Hello. I wanted to make a quick video over practice test 3 and just going over every question step by step, just so we have, one more point of contact before the actual final. So I'm just going to go through this step by step. It'll be kind of quick, but I'll at least be able to go through it. So I'll just go ahead and start, right? So first two questions. Find a positive and negative coterminal angle for each given angle. So a coterminal angle, if you remember, is just an angle who is some number of rotations past our original, right? So what that ultimately boils down to is adding or subtracting 360 some number of times, or adding or subtracting 2 pi some number of times, right? So for 180, we can add 360 to that. When we do that, we get 540, right? So 540 is an option right here. And we can also subtract just to see what happens. And when we do that, we get negative 180, right? So option A is the one, is our answer, okay? The same thing for number 2, except we're adding or subtracting fractions, right? So negative 11 pi over 12 plus 2 pi, which is actually negative 11 pi over 12 plus 24 pi over 12. And that is 13 pi over 12. And then just to check, we could do negative 11 pi over 12 minus 24 pi over 12, which is negative 35 pi over 12, which is, again, option A. Right, so adding or subtracting just different numbers of rotations. Number 3, convert each degree measure into radians and each radian measure into degrees. So really we need to convert this 315 degrees into radians. And in order to do that, we do 315 times pi over 180. And really we just simplify that. Right, so 315 divided by 180. That's 7/4. Add that pi back in, and again, option A is our answer. Okay, 4 and 5 I haven't changed in any of the practice tests, and I apologize for that. But I'm gonna at least run through the thought process. These numbers will be different on the actual final, but right now they are not. Okay, so for number 4, find the radian measure of the central angle of a circle of radius 13 feet that intercepts an arc length of 14 feet. So the equation we need here is S is equal to R theta. Right, so S is arc length, R is radius, theta is our angle. Right, so if we just look at this, find the radian measure of the central angle. So we need to find theta. We're given a radius of 13 feet. And we have an arc length of 14 feet. Right, so we have S and R, and we need to find theta. Right, so if we just plug those in, we get 14 is equal to 13 times theta. Solve for theta. So we get theta is equal to 14 divided by 13. So that's C. Okay. Same thing for number 5. At least I haven't changed it. The equation, though, for the area of a sector of a circle, A is equal to 1/2 R squared theta. So if we plug all of that in, we need to find the area. So we need A. We have a radius of 7 feet, and we have an angle of 8 pi over 7. Right, so A will equal 1/2 7 squared times 8 pi over 7. Right, so A is equal to 49 halves times 8 pi over 7. When we do that, so 49 times 8 pi divided by 14, and we get 87.96. That'd be feet squared. So that'd be our answer. Okay, but this equation is something we need to know. Also, for both of these things, for both number 4 and number 5, I could give you any of those variables, and you'd have to solve for the other one. All right, so number 5, we just happen to find A. Number 4, we just happen to find theta. We could solve for r, we could solve for theta. It doesn't matter, right? We do need to be able to use those equations though. Number 6, find the exact value of each trig function. I'm going to start with number 7 here because number 7 is actually a little bit easier. So we need cosine of 270. So remember, cosine on a unit circle always gives the x value. So if we go to our unit circle, go to 270 degrees, we're looking for the x value at that point. Now this happens just to be 0. Right, but again, you'll have that unit circle, you go to 270 degrees, you find that x value, and that's our answer. Okay, number 6 is a little bit more complicated. So we have this angle, 1020. We need to find what that angle is, or we need to find coterminal angles of that. We need to find the simplest coterminal angle of that. So what we can do is we can just count rotations. Right, so this angle right here, that's 360. This angle right here is another 360. And then we have to go some other distance or some other angle to get to 1020. Right, so if we add 360 and 360 together, we get 720. And then the rest of the angle is just 1020 minus 720, which is 300. Okay, so this angle, right, this angle in orange here, that's just 300 degrees. Okay, so the rest of the process is the same. We go to 300 degrees. We want the y value over the x value. Right, so if we do that, let's see, 300 degrees, our y value is negative rad 3 over 2. Our x value is 1/2. If we simplify that, we just get negative rad 3. So that's D. Okay. Number 8, find the measure of each side indicated, round to the nearest tenth. Okay, so we are given an angle. X is our adjacent side to that angle, and 4 is our hypotenuse. Right, so we have an adjacent side. We have a hypotenuse. And we have an angle. Right, so one of our trig functions has all of those things. So that'd be cosine. So cosine, sorry, this should be 68. So cosine of 68 degrees is equal to x over 4. If we were to solve for x here, we'd have 4 times the cosine of 68. And once you get here, you go to your calculator, make sure your angle, make sure you're in degree mode. So if you go hit mode, go over to degrees, highlight that, and then do 4 times the cosine of 68. You get 1.5. Really 1.498. 1.5 though is the answer. Okay. Number 9, find the measure of each angle indicated, round to the nearest tenth. So in this case, we are trying to find theta. So we do this kind of the same thing. We set up kind of tell ourselves what we have and what we don't have, and we solve for the rest, right? So theta, we need theta. From theta, we have the adjacent side. And from theta, we have the opposite side. So if we just set up a trig function with opposite, adjacent, and an angle, right, that'd be tangent. So tangent of our angle is going to be equal to 6 over 10. Now, you don't have to show this part, but in order to undo the tangent, we would take the inverse tangent of both sides. And what that does is it cancels out the tangents on the left, so we're just left with theta. And then that will be equal to the tangent, the inverse tangent of 6/10. So again, you go to your calculator, you hit second, and then tangent. Type in 6 divided by 10. and that gives you 30.96 degrees, which just rounds to 31. Right, so D is our answer. Number 10, find the value of the trig function indicated. So we're just trying to find the ratio here, right? So we're given theta, we're given an opposite side and a hypotenuse. So our opposite is 6, hypotenuse is 10. Cosecant of theta is 1 over the sine of theta, which is just 1 over y. Or sorry, 1 over opposite over hypotenuse. It's a better way to write it. So this is 1 divided by 6 divided by 10. So if we just simplify this, just 10 over 6. You can either look at it the way I did this, which is probably a little bit trickier. I don't know why I did that. Cosecant is just the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So our answer is 10 over 6, which I guess simplifies to 5/3. So C is our answer. Number 11 and number 12 are simple, so I'm going to do that in one like blank here. But it involves graphing trig functions. Okay, so the first thing we need to do is we need to do a little bit of footwork. We get the vertical shift. That's going to be 2. We get the amplitude. It's also going to be 2 because of this number. We need a period. That is going to be 2 pi over whatever's attached to theta. So 2 pi over 2, which is just pi. We need a start point, which is going to be when everything inside parentheses is equal to 0. So 2 theta minus pi over 4 is equal to 0. Then we solve, right? So 2 theta is equal to pi over 4, and theta is equal to pi over 8. Then we also need an endpoint, right? So the end we could just find by doing the period, or sorry, the start point plus the period which if we do this, we get pi over 8 plus 8 pi over 8, which is equal to 9 pi over 8. Right, so this is our end, this is our start, period, amplitude, and vertical shift. All right, so then we can actually start to draw stuff. Our center line is going to be the vertical shift. From that we go up to 4 and down to 0. Actually, I'm going to make these a little bit closer together. All right, so that tells us where our maximum of sine is and our minimum of sine is. Okay, then we actually draw sine. So sine starts in the middle, goes up to a maximum, and then back down to a minimum, and then back up. Okay, and then our job is to label points. All right, so this start point, we already have all of it, right? So that's pi over 8, comma 2. This endpoint, again, we already have this. This is 9 pi over 8, comma 2. And we need to find our maximum, our minimum, and in between. Okay, the easiest thing to do is to find the middle, right? So the middle value between pi over 8 and 9 pi over 8 is what we're trying to find. So if we think of the midpoint of 1 and 9, we just add those two things together, divide by 2. So that's 5. So this midpoint is 5 pi over 8, and still comma 2. We do the same thing for the maximum, right, except we're looking at the midpoint between pi over 8 and 5 pi over 8. So 1 plus 5 divided by 2, let's just give us 3. So this point right here is 3 pi over 8, comma 4. So that means this one will be 7 pi over 8, comma 0. Okay, and you could do that the same way, right? So 5 plus 9 divided by 2, that's 14 divided by 2, which is just 7. Okay, so those are all of our points. That is the first part, so that's number 11. All right, if you get all of that, you get full points. Number 12 says to graph the inverse, right? So for number 12, we're really graphing y is equal to 2 plus 2 cosecant of 2 theta minus pi over 4. And in order to do that, nothing really changes. Okay, wherever our sine graph crosses that center line, we have an asymptote. Right, so we have asymptotes at pi over 8, 5 pi over 8, and 9 pi over 8. This is going to look a little bit messy because it's all in one graph, but you get the idea. And then our maximum is, this point is still the same. So we're just going to leave that there. But from that point, we draw up toward our asymptotes. From our minimums, again, this point is the same. And then we draw it down toward our asymptotes. Right, and then that is number 12, right? So number 12, you're really just taking most of the work you did for number 11 and then graphing cosecant out of it. Okay, so that's 11 and 12. Number 13, verify the following identity. Again, I know I haven't changed this in any of the practice tests I've given, but we still have to know. Granted, it'll be a little bit simpler than this one. It'll be more like the quiz we had. But just in terms of process, we need to make the left-hand side equal to the right-hand side. All right, so in this case, I'm going to add these two fractions together. All right, so in order to do that, we need a common denominator. So the left fraction, right, so sine over cosine, I'm going to multiply by some clever form of 1. That clever form of 1 is going to be sine over sine. And then the right fraction, cosine over sine. I'm going to multiply it by another clever form of 1, and that's going to be cosine over cosine. And when we do this, we get sine squared plus cosine squared over sine cosine. Again, to think about adding fractions here. So that's, like, if we get here, we're in really good shape. But just to finish it off, right, sine squared plus cosine squared is just 1. That's an identity. That's a Pythagorean identity. And then we have 1 over sine times cosine. One over sine is just cosecant. One over cosine is secant. Right, so then we get what we wanted, right? Cosecant times secant. So then that's our proof. All right, so that is the entire test. Again, I know there's a couple problems that I haven't changed on there, but hopefully that helps at least direct studying. So that's all I've got. I'll try and make myself available in the next couple of days. But I hope this helps a little bit. All right. Thank you.